Cool. Good morning, everyone. Today we're going to be talking about building an MLOps stack from scratch. So there's quite a bit of content to cover, so I'm going to jump in. As usual with webinars, for those of you who have maybe been to some of our webinars before, you can always ask questions in the Q&A if you're on Zoom. If you're on LinkedIn, you can leave questions on the live stream, and we will get to those and answer those as well. Otherwise, let's jump in. So we're going to be talking about building an MLOps stack from scratch. Before we dive into that, I think it's really important to talk about the ML model lifecycle. All ML, AI, etc., it all starts from data. So the first piece of the lifecycle is data. That's data engineering, analysis, feature engineering, feature serving, anything that has to do with the data part of ML. Next, we have experimentation and training, where we actually get our model and turn it into, train it. Once we have a trained model, the next big problem to solve is getting that model into production for serving. For online models, that could be a deployment that is constantly running. And for certain types of scoring models, it could just be running in batch on some time period. And then finally, monitoring and evaluation. Once the model is in production, data changes, things change. As things are changing, you need proper monitoring and evaluation tools to be able to kind of feed that back in to enhance your training again, maybe change your feature engineering and data set creation. Within these four columns, parts of the L lifecycle, there's two sets of problems to solve. There's what I'll call the engine problem and the workflow problem. Let's start with data first. So with data, the engine problem is how to serve data under some amount of milliseconds, how to deal with streaming data, how to process large data sets, how to deal with unstructured data. There's all these problems where you need to have the right engine, which can process the data the right way. Then there's the workflow problem for data. How do you do versioning, analysis, get your feature pipelines in production, have proper monitoring and lineage, allow for sharing, reuse, collaboration, and then govern all this stuff. So this is kind of the first layer. It's kind of the first thing to think about when you're building an MLOps stack from scratch. It's important to think of, one, the ML lifecycle, these four things, and think of what's the proper workflow and tooling you need for all of these things, whether that be in-house or a vendor. For the data part specifically, feature form works on the workflow and orchestration bit for the data for ML. So we work on top of Databricks, on top of Snowflake, etc., and make that into a data platform for machine learning. Next, we have training and experimentation. For the engine, we need something that maybe we can pass training config to, and it'll actually train for us. It might have some stuff around distributed training, GPUs, maybe it does some hyperparameter optimization, etc. Since we'll likely train many different types of models and many different models, we also want to have proper workflows for experiment tracking, to track models, to compare and contrast different runs that we've had, etc. Next is deployment. For deployment, there's also, again, two problems. The engine problem, you have this model, you want to run it, you want to make sure it's fast, you want to make sure it's properly using GPUs, you want to make sure it scales. For the workflow, you want to worry about A/B testing, upgrades, downgrades, canary deployments, having a proper API. There's kind of the continuous delivery bit for that as well. Finally, there's monitoring and evaluation. For the engine, we're going to be serving potentially lots and lots of requests. Having a proper engine that allows you to log all of the things that you've done and be able to perform analysis on those logs is critical. The other bit is the workflow. The workflow is kind of typically more of a UI for monitoring and evaluation, which gives you proper visualizations. It kind of paints a picture of what's happening in production, and also potentially has alerting and the like. So it can let you know if something's happening. There's tons and tons of tools here. There are tools at the platform layer, like Kubeflow, Flight, etc., that kind of have different plugins for all these pieces. For our workflow tools, like Featureform, MLflow for model experimentation, there's things like Selden for serving, there are things like YLabs and Arise for monitoring. For the engines, for the data bit, there's Snowflake, there's Spark, there's Ray for feature serving or for training models. There's all these different tools. Today, though, we're going to keep it really simple. Today, we're going to be working specifically on AWS. For the data bit, we're going to be using Featureform on top of EMR with Glue and Iceberg, which I'll get into, as well as DynamoDB. For training, we're going to use the training jobs in SageMaker. For inference, we're going to launch a model endpoint, and then we're going to ignore monitoring the evaluation for this workshop. But that's something that could be easily expanded onto. So that's what we're going to build today. We're going to, from scratch, we're thinking about these problems. If I was building an MLOps platform from scratch, I would first look at these 4 parts of the model lifecycle. Do I have data set problems? Do I have training problems, deployment problems, monitoring problems? Typically, it's usually the data problems or the monitoring problems that are sharpest. It's usually one or the other. In my experience, computer vision use cases have a focus on monitoring and evaluation. And then for things like recommender systems, fraud detection, etc., the problems tend to be more around the data. So those are typically the 2 that are most painful. If I was building an MLOps stack from scratch, I would think about the level of complexity I need. And likely, if you're starting from scratch, you don't need to start with that high of complexity. So figure out which of these are the biggest pain points for your end user. Once you have that, you can decide what the proper tooling is to use. There's nothing wrong with starting with the generic SageMaker, etc., just to kind of get a feel for some of these problems. Typically, though, you're going to want to have the best-in-class parts for the bits that are most painful. So, for example, if you have problems with data sets, features, etc., Featureform is going to be dramatically better than the kind of default services that come in AWS. Great. So that's what we're going to do today. We're going to deploy, we've deployed Featureform. We're going to build training sets. We're going to train a model. We're going to serve it, all using Featureform and SageMaker together. So I'm going to just show that code first. I want to walk through that, and then I'm going to come back and talk through the workflow more. So I have this sandbox I'm running. This Jupyter notebook is actually running on a notebook instance in SageMaker. So SageMaker lets you run instances that run notebooks, and you can use this to interact with a lot of SageMaker's native tooling. So it's a good place to start, especially, again, if you're just starting from scratch and trying to get a feel for things. With Featureform, I first create a connection to the client. So I've deployed it, create a connection to the client. I then register all of my providers. Could be, in this case, I'm using Databricks. We support EMR. I'm registering S3. I'm registering Dynamo. I'm connecting all the infrastructure. The bits you need to properly do data for machine learning is really just 2 parts. One part is called the offline store. This is where you actually run compute, where you build your features, you build your training sets, and for training, it's where the data comes from. Then you have optionally an online store or an inference store. In this case, we're using Dynamo. An online store it gives you low latency serving of features. So for example, if you are doing a recommender system and you want to know the last 5 items a user clicked on, you don't want to compute that with a Snowflake query. It's going to take way too long and be way too expensive. You'd much rather continuously compute that stuff or materialize it on some timescale into an online store like Redis or DynamoDB. So first, we register our providers. We tell feature form, here's where my infrastructure is that I want to run things. Next, we would register our primary data. These can be CSVs, these can be tables and like Postgres. It can be a bucket in a directory in S3, etc. I've already done that. I've already set one up. And so here I'm just getting that source and then I'm converting it to a data frame. In feature form, everything can be converted to and from a data frame, which makes it really easy to iterate, evaluate, understand things. It fits nicely into the workflow. Next, when we learn machine learning, we kind of imagine and see that we have these perfect data sets that we can just go and train on. In reality, though, that's not how things work. In reality, there's a lot of work that goes into taking this raw data and transforming it into something useful that we can actually use. For example, we have here just a very simple transformation called percent balance. In percent balance, we take the amount of a transaction, we divide it by the customer's account balance. So like what percentage of this person's money does this transaction make up? We handled the situation where the balance is 0. We just set it to 30%, just for this example. When we run this, what's happening is feature form is running this as a job on EMR. So this is a Spark job that gets run. It generates a iceberg table, which I'll get into why we use iceberg and what that allows for. And that iceberg table can be used for training. And also we can just retrieve it as a data frame like we do here. We can build labels. We can build much more complicated transformations as well. We can define our features, our labels, our training sets, bring all of this together. So as we do all this, what we've done is we've taken raw data using feature form on top of EMR and Dynamo. We have taken that data and turned it into our features and training sets. So now we can train a model and we can also do inference. So we also specified the inference store here. I think I called the variable Redis, but it's actually Dynamo. And by setting the inference store, like we do here, this is actually copying the features into Redis or into Dynamo. So we can do low latency serving, which I'll show in a bit. So now we have our data. Now we can use it. Now we can train models and we can actually use these features in production. And just to show you a sense of what the training set is, you can convert it to a data frame. You can see you have all the features and the label that we have here. Next, we can train. So to train, we're going to use SageMaker, like I said. So SageMaker has an endpoint called estimators. With estimators, you can specify some hyperparameters. You can specify a model you want to run. And finally, you can call train. When we call train here, we actually point it at the training set and feature form and tell it, hey, here's the training set and feature form. I want to train this model. This will actually run a instance, in this case, M4 large, X large instance. It will train the model and then it will output, it will save the model that it trained. I'm not running this because it takes a while, but you can see that when I ran it last, you can see the model was trained. It puts out a ton of random output, but eventually it finishes the job, completes the training job, tells you how much it costs, and then it saves the model. So let's go back to our workflow so far. So going to our breakdown of the MLOps stack, we started with the data. So we use EMR and Dynamo as our engine, and we use feature form to version our feature transformations, orchestrate them, keep them up to date, etc. Next, we went to the training experimentation. So SageMaker, we use SageMaker directly to do the training of the model. We didn't really set up an experiment tracker. I've done other webinars of MLflow, which is one that we use and recommend often. With MLflow, you'd be able to see all the training runs that happen and compare them if you're training multiple models. Now we need to deploy that model. So we finally need to get that model into production. So let's do that now. So going back to the sandbox, we can in SageMaker, we use things called endpoints. Endpoints are just deployed models. It kind of gives you a endpoint that you can hit, and it will do inference on whatever you send. So in this case, I take that classifier that I trained, and then I tell SageMaker to run on an endpoint. And you can see here that the endpoint gets run, and it's usable. Now, with feature form, this is the feature form client, I can retrieve any features I want for any user. I can specify the model that I'm using. That's just optional to get lineage. And then I can use that endpoint, which is called predictor, to make a prediction on the data that I got from the feature store. So here what I'm doing is at inference time, if a user makes a transaction, I want to see if it's fraud, I can use feature form to retrieve very quickly via Dynamo the features that the user that are relevant to this model. And then I can actually pass that into the model to do inference. The other really nice thing is that all the things I created, all the features, all the labels, all the training sets, everything is in the feature form UI. So that I can see different versions that were created. I can see the logic behind it. I can see which models, which training sets, which features are using what. So I get all of this context and all of this information in the dashboard, which is really, really valuable. And that's how it all comes together. So it's not rocket science. It is possible to kind of quickly put up an MLOps stack from scratch, especially if you start by just leaning on to some of the SageMaker in this case. You can put all this together. We're going to be doing other webinars with Metaflow and some of the other products that we integrate with. But this is, I think, a really easy, fast example of SageMaker. I think as you're thinking about the stack, one thing to keep in mind, I think a lot of times when you teach MLOps, like we do, like I just did here, there's this focus on like, I have everything perfect. I have the transformations I need. I know exactly what my hyperparameters are. I know I'm going to deploy this thing. But the reality of machine learning is it's never that perfect. There's always this experimentation stage. And I think this is often forgotten in MLOps. Because this needs to be operationalized as well. We need to make it easier for engineers and data scientists to quickly be able to experiment with pandas, polars, DuckDB, whatever, in a notebook, be able to iterate quickly, try different models, try different features, come up with good ideas. And then our next job is to help them get those things into production. In the case of features, like in this case, the idea is with notebooks, you might be working with data frames and the like. But when we go to production, we now need to worry about Spark jobs. We need to worry about incremental processing, maybe streaming data, maybe on-demand features. There's a lot more complexity there. Because what happens a lot that we see all the time is that data scientists have these perfect models and features in their notebook, but they're unable to deploy them in production because the bar to get it to production is so high. So the goal is to make it much easier to productionize machine learning. So like I said, at any time you can ask questions. I'm going to keep going through this here. I want to talk a bit about the workflow that we recommend. How do you go from experimentation to production with feature form for the data pipelines of your features? Our my view is that the Terraform-like approach is the correct approach. So we very much copied the kind of Terraform ideology that they do for data for infrastructure and applied it to features. The way that works is in Terraform, if you've used it, you have these files, you create a plan, and then you apply that plan. And so what Terraform does is it kind of takes the diff of your infrastructure and updates things. How that looks in feature form is you can give feature form a set of features, your data pipelines, etc. You can plan and apply it. Feature form will update all of your pipelines to generate all those new features, build those training sets for you, and materialize them into production. The way feature form works under the hood is simpler than this makes it look. There's really two ways to interact with feature form. There's the Python client and then the dashboard. So I showed you the dashboard and I showed you some code in the client. These things interact with the API in different ways, but really there's three core components. There's the metadata component, which is like the plan, like this is the state that you want to achieve. There's the coordinator, which is going to work across your EMR and DynamoDB or Snowflake or whatever you use to build your features and make your stuff exist in Snowflake and Dynamo, and then finally allow those to be used for serving. Someone asked if I can send over the workshop and slideshow after, and I plan to. We're also going to send a video of this as well. So why I'm showing this is to show that there's actually a lot more complexity than just giving a data scientist access to EMR and Dynamo and calling it day. What tends to happen there is just, like I said, that chasm between the notebook with pandas in it and the actual production setting using Snowflake or Spark or Dynamo is too high. So part of the goal of feature form and similar things is to make it easier for data scientists to just get these features into production quickly. The workflow, just to really nail it down. This is, I think, how the workflow should work across ML, but we're going to talk a bit about feature form style. First is the development style. In development, you're working in a notebook. You're trying things, interacting with data, experimenting, maybe training small models in the notebook. When you have something you want to get into production, you can take the relevant parts of the code and update a code base in Git, put your new feature definitions in Python into a directory. Let's call it the features directory. After it gets merged, CI/CD should apply those things. That will go into staging, where it will be validated. And then finally, it will go into production. So the notebook is really oriented towards kind of quick, fast things. And I think if you're building an MLOps stack from scratch, again, this part is really forgotten often. Either people hyper-focus on the notebook workflow or they hyper-focus on the production workflow. The reality is you need to do both. You need to make it easy to go from notebook to prod. So it needs to work in both settings. Like I said, first you work in a notebook, again, step. And then when you merge, you kind of go into staging, do validation, and go to production. Cool. The last thing I want to talk about today is Iceberg and performance. One thing that we've moved to and we think most people should move to, if you're building an MLOps stack from scratch today, I would highly recommend that you use Iceberg as your data format. So those of you who are unfamiliar, Iceberg is a table format. It's just a way to store a table in S3. So with Iceberg, you provide a it's really just a representation of a table. Under the hood, It's a lot of Parquet files with a ton of metadata files pointing to things. So it's complex, and I'll talk about why it's so complex, but the use case is just a way to store structured tables in S3. Once you have those structured tables, Iceberg gives you a lot of really cool things. One thing that we use quite a bit at Featureform, one is snapshots. This allows you to be able to actually look at data sets at different points in time. You can see incremental changes, where I can see since a certain point in time what rows have been added, deleted, changed. I can do merge on reads. So whenever I'm writing, rather than updating files, I can create lots of new files. That's fast to write, but when you read, it's expensive, more expensive. So what it will do is when it reads, it will actually squish those files back together, which makes writing really quickly, reading slightly slower, but for lots of ML use cases, it's actually what you prefer. And then finally, there are pushdown predicates. This allows you to create indices. So you can specify a column as an index and sort by it, kind of like how you would a typical table in the database. But again, this table is much larger, stored in S3, and can be computed via Spark, Snowflake, ClickHouse, a lot of other things. It also has a lot of other benefits, unified streaming and batch. So to conclude, I'll send a notebook, like I said, but we've put together a really simple end-to-end example of how to use SageMaker and Featureform together to get your features into production and be able to train and do inference. Like I said, most of the time, the data tends to be one of the most painful bits. And so we focus a lot on the data bits today. There's a lot of, using Spark, using these things that scale really well adds a ton of complexity, especially if you start adding Iceberg and other things. Our goal of Featureform, and Featureform is open source, by the way, is to make it possible for data scientists to essentially unlock data engineering for ML end users and data scientists. This allows them to define features as SQL or PySpark and have Featureform handle all the complexity to get those features into production for training and inference using all the newest cutting edge data engineering tools and patterns. Awesome. That's all I have for today. If you have any questions, feel free to throw them in the Q&A. Otherwise, if you're on LinkedIn, you can also throw them in comments and we'll be looking at those, and I'm happy to answer any questions that you may have. So I'll give it a minute, see if anyone has any questions. Cool. Rumi, why don't you take over and see if, talk about what happens next. And if someone has a question in the meantime, they can throw it in the Q&A.
Sure. And I'm looking out on LinkedIn in case anybody's on LinkedIn and has a question there as well. But in the meantime, thank you guys so much for attending the webinar. After this, I'll send you guys a recording of the webinar so you can take a look back. I can also send the slides as well, and I'll send you guys links to our Slack community if you have any further questions, links to our docs and GitHub if you're interested in trying out Featureform open source. But otherwise, thank you guys so much.
Great. And there's a question in chat, which are what are ways I can practice on my own? It's a really good question. I'm going to assume that you're working on your own and you don't want to spend any money, like on AWS and stuff, which I would typically recommend. If you have access to AWS and you don't mind spending a little money, I would just go through the notebook we went through today. If you're trying to work locally, that's also totally possible. We have a quick start in Featureform that shows you how to build training sets and train a model. It all runs locally. You just have to have Docker set up. And you can go to our docs at docs.featureform.com and go through the quick start. If you have any questions and you want to go through it, you can join our Slack community and you can ask questions there. But it's a great way, I think, to get started. Again, most ML starts at data. So it's a good place to start. It's just starting with the data, getting an understanding of that data, and then moving for the other stacks, parts of the stack we talked about. But in general, just using Docker, using local tools, trying to use open source where possible. Today we use AWS, but so there's a question, where's the Slack community? So Marie's going to send a follow-up and it will include a link to the Slack community. And you can also go to our GitHub, feature form GitHub, and there's a link there, but you will get it in a follow-up email as well. Awesome. Great. I think that's everything. Thanks, everyone. If you have more questions, you